Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Harun Hazra bin Fazil. Today, I will start the presentation of our group. So, this is the topic subject control system. We are from group 15, section 2. So, my group consists of 5 members, which is Nurul Humaira binti Jeffrey, Nur Elisa Muiz bin Muhammad Zaini, Nick Harun Hazra bin Fazil, Putri Aisyah Nurdini binti Sahadan, and Nur Fariana binti Samburi. So this is the table of content. This slide includes introduction, literature review, explanation each questions, and lastly, conclusion. So first is the introduction. Our introduction includes of 3 topics, which is DC motor, PID, and block diagram. First, DC motor. An electrical motor that transforms direct current, electrical energy into mechanical energy is known as a DC motor. A magnetic field is produced in the stator of a DC motor when it is energized. The commutator, which is connected to brush and the power source, supplies current to the motor's wires windings in order to keep the rotor turning continuously. Next is the PID. It stands for proportional, integral, and derivative. In order to precisely manage the process, eliminate oscillation, and boost process efficiency, PID controls offers a continuous modification of output within a control loop feedback mechanism. Not every controller needs all the PID components. Many may get by with just the proportional component, while others can manage with the proportional and integral components alone. Lastly is the block diagram. Fundamental tool for developing, describing, and representing the workflow and processes of hardware or software system. It is used to describe systems and how they change, such as the mechatronic system used in the trucking industry. The basic elements of a block diagram are a block, the summary point, and the takeoff point. The schematics are helpful for resolving technical issues.
Assalamualaikum, my name is Nurul Humaira binti Jeffrey with number matrix DE210052. In this literature review, based on this study, we gain information and understand basic theory and application of component that related in the project given. For the closed-loop system, also known as mechanical or electronic device, it is used to maintain a desired state or set point without the need for human intervention, and the system is proved very accurate because there is correcting action by the controller. For the gear system, there are many mechanical devices contain gears because they offer a gear reduction in motorized equipment due to the small motor spinning capacity that can only provide a device with a limited amount of torque. With gear reduction, the output speed can be reduced while the torque is increased, and the deal RPM for any motor is 1,500 to 3,000 RPM. The third one is the PID controller. The PID controller performance depends upon 3 design parameters, which is the proportional gain, integral gain, and derivative gain. And it is popular because of the simple formulation and implementation. But one of the major challenges lies with the tuning of parameters Kp, Ki, and Kd that have to be adapted to deal with different, often conflicting constraints on the regulation process. And one of sample method for tuning PID controllers is Ziegler-Nichols. It can only be tuned using the closed-loop system and cannot operate in an open-loop setting. The last one is DC motor, which is the any rotary electrical motor that converts direct current, which is DC, electrical energy into mechanical energy. We have 2 parameters for DC motor, which is inertia and torque constant. The inertia may be changed due to the mechanical configuration of the motion system itself, and the torque coefficient will vary according to the rotor position of the electric motor due to regular distribution of magnetic flux on the surface of the rotor. And for the problem elaboration, we have the cement mixer speed control system for our task, and the DC motor used as an actuator in the control system to drive a blade, and the block diagram to show both electrical and mechanical parts. And from that, we derive its mathematical model and block diagram as input, which is the rated motor terminal voltage, and the output is blade speed. And this one is the DC motor data given for the Siemens mixer. And one more is the gear data. From all the data given, we have to use our theory, techniques, and concepts that have been learned in control system. And we have to use software such as MATLAB Simulink to create the block diagram. And also we have the popular method for tuning PI, and PID controller, which is Ziegler-Nichols, to do all the implementation.
Hi and good day. My name is Nur Faraliana binti Samburi. My metric number DE210111. I am from section 2 and group 15. I would like to explain how I solve for equation A, which is derive its mathematical model and block diagram. Input is VA and output is blade speed omega R. And question B, determine PID gain manually. Mathematical modeling. So this is for solve equation A. Laplace transform of armature circuit equation, VES. So this represent as equation 1. Next, Laplace transform of electromechanical equations. TMS is torque. Since torque is directly proportional to the current, so TMS equal KAIAS. Next, EBS is the back EMF. So EBS is directly proportional to the angular velocity of the motor. So EBS equal KBS omega MS. First equation applied to motor. So this is the new equations. Next, JM plus JL is represent as JR. BM plus BL represent as BR. From the equation 2, put IAS equal TMS equal over KA. Substitute equation 5 to 4 and we will get this equation. Next, substitute equation 3 and 6 into equation 1. So, this is the new equation and represent as equation 7. Assume this equation as ZA, then insert ZA into equation 7 and we will get these new equations. Output over input, omega MS over VAS equal KA over ZA plus KA KBS. Next, insert equation ZA into this equation and lastly we will get this new equation. Total amount of inertia and viscous friction. JT equals 0.444 kgm square and BT equals 0.0035 nm as inverse radian. Next, insert the value of DC motor data into the equation. The data is given in the equations. Then, insert the value into the equation and lastly we will get the transfer function. Next, we have to create a block diagram. So, this is the block diagram for our group. Question B, manual tuning of PID gain. Characteristic equations. Assume transfer function as GS. By applying this equation, insert this equation into the transfer function and we will get this equation. By applying rough array, insert this value into the table, find the value of A and B. Cross multiply A equal to this equation, B equal to 1.28K. Step 1, put the value of A greater than 0. So we will get K less than 118.586. Step 2, put the value of B 1.28K greater than 0, so K greater than 0. By using the stability of system checking, K is the stable condition. Next, value of K critical. KCR equal to K equal to 118.586. Next, for imaginary roots, insert the value of KCR into the equation and S equal to 5.5246. The sustained oscillation at the limiting value, KCR equal to 5.5286 radian over seconds. PCR is period oscillations equal to pi over omega equal to 1.14 seconds. For PID type E, find the value of Kp. So insert the Kp formula and we will get 59.293. Next, for PID type Pi, find the value of Kp, Pi and Ki. Next, for PID type PID, find the value of Kp, Pi, Ki, Pb and Kb. And lastly, insert all the value to the table 1, which is for PID controller gain from manual tuning.
Assalamualaikum, my name is Putri Aisyah binti Sadan and my metric number is DE210087. Now I'm going to explain about question C, which is create the system block diagram and manual tuning PID controller on MATLAB Simulink and attach on the report. First of all, this is the basic diagram for the manual tuning PID controller. It has step, subsystem, bus creator and scope. For the subsystem, we need to double click it and put the block diagram that we get from question A. The block diagram have in and out, positive negative sum, transfer function, integrator and gain. The value for transfer function and gains can be referred to the data given in the instructions. Next, we need to run the simulation. Then double click scope to get the graph output. This is the graph output that we get from the basic diagram. From the tools here, we can get the measurement of signal statistics and bi-level measurements. Next, we will move on to question D, which is implement PI and PID controller using PID gain from table 1, system without controller or open loop, and plot the response, each of their response versus input signal or step signal. So this is the table 1 that consists of P, PI and PID value that we get from the manual calculation. Next, this is the P controller diagram that has two subsystems. For the subsystem, we still use the same block diagram and we put gain over here with the value of 59.293. We also need to change the value for step to 1500. Click run to simulate the diagram and double click the scope to get the graph. This is the graph for the P controller with input of 1500. This is the diagram for PI controller. For this type of controller, we add another subsystem and also two gains to represent the value of Kp and Ki. We also add an integrator and sum. The value for Kp and Ki can be get from table 1. Now we will change the step input. Now we can click run and the scope. So this is the graph when we put the step signal as 1500. The last one is PID controller. Now we will change the step input. Click run and double click the scope to get the graph output. The output graph for value 1500. That's all for question C and D. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Elisa binti Muhammad Zaini with matrix number DE210049. So today I will be explaining about question E, F and G. So based on the question E, create the system block diagram for automatic fine-tuning PID controller on MATLAB Simulink. So as you can see, here's the auto tuning system. So how to create this is you need to click on the library browser over here, click it and then search for this one. This one is a sum, so just type sum and enter. So this is the sum junction. The next one is the PID controller. So click the first one. Next is the subsystem. So this is the subsystem, and then this is the bus creator. So click this one, and then the last one is the scope. So this one, and then you just need to put it here, and as you can see, how to connect it is by click on this one and then just put it on the line here. Same goes to all this, and then after that, this is for question E. The next one is for question F, which is develop a table for comparing the PID controller gain from manual and automatic tuning, table 2. So this one, as we know, the upper one, which is the upper one, is the manual system, and the one that we just create on the bottom is the auto one. So how to run this is by clicking the PID. We need to set up the PID first. So this one is for the PID, so change based on the PID over here. And for the filter coefficient, change it to 100 and click internal. And for the tuning method, select transfer function based PID tuner apps, then click apply over here and then tune it. It may take time, so you just need to wait. So the graph like this will pop up, and this one is for the auto graph. And if we update the block over here, so this kind of graph will pop up. So as we know, for question G, how to read it, this is actually the comparison between manual and auto graph. First thing is we need to run this one. So after run, we can see the scope over here. This is for the manual graph, and if we click on the scope 4, this is for the auto graph. And then if we click on the scope 5, this is for manual and auto graph. So as you can see over here, how to pop up the trace selection on the right side is by clicking on the ruler here and just click all of the icon. So you can see here, we can know the measurements of the amplitude, rise time and everything. And how to read for question G is by clicking the subsystem over here for this trace selection. So if we want to see, okay, actually the blue one is for the input. So if we want to see for the input, we just click step. So it will pop up, it will change the color to blue, which is for the blue graph. So you can take the data and put it on question G. The next one is subsystem, which is the manual graph. So same goes here, and also for the auto, which is the red one. So that is the comparison between the manual and auto graph. So click show parameter over here, and we can see here the difference between tune and the block. Tune is for the auto and block is for the manual. So we can see over here there's a value for the rest time, settling time, overshoot, peak, gain margin, phase margin, closed loop stability. This one is actually for question G, which is plot comparison to PID controller response, which is for the input, manual, and automatic. And I think that's all from me. Thank you.
Okay, now for the conclusion. For overall assessment, we had construct a controller for a DC motor to establish a door opening control system in accordance with the provided and specified characteristics and parameters. A proportional controller, KP, will shorten the rising time based on the result of the simulation while leaving the steady state error unsolved. By improving system stability, reducing overshoot and successfully decreasing overshoot using a derivative control, the transient response will improve. While eliminating the steady state inaccuracy, an integral control will considerably improve the transient response. Students are able to derive the mathematical model and block diagram, then determine the PID gain manually. To sum all of that, after trying and success in the assessment, it proved that students can get better understanding and know the basic theoretical by applying it on MATLAB platform. So that's all for our group. Thank you.